I'm Joel, programming as well.
Okay. Long and Joel. Yep.
I'm Nabil, in the artist.
Nabil, artist. Cool. Okay. All right. Sweet. So, what do we need to do?
Yeah, I love
So, if you guys have got questions that'll help, because I assume you're following a plan, right? So you guys do that, and basically, you know, this in some ways this is your project, right? But I'm the one who's providing the kind of like, you know, the content or the vision in that context. I'm really excited about what you guys can come up with. That's all I want.
Yeah.
We've got particular ideas, but let me put it this way. I recently built a house. I thought I wanted to have this. I asked my brother, who's studying architecture, to design that. He designed it. I was like, okay, there's a couple of problems with it, whatever. And he's like, you know, I'm going to get some help from an expert. So the expert went off. So he went off. The expert said, let's design from first principles. What's the shape of the block? All these kinds of things. They came back with something completely different to what I actually thought I wanted, but it was much better. Okay? We're quite happy to do that here. So we'll tell you what we want, but we don't mind if you guys sort of say to us, that's not what you want. You want this. All right? So you see what you can come up with. So there's a bit of creativity there, but if you're finding that having that much freedom is making it difficult, then let's, you know, focus on the minimum viable product, and then we'll move forward from there. But I want you guys to know that there's flexibility here. We're happy to work with that, and you've got a big team with some skills in here that I was not expecting. Like having an artist is great. I'm really excited about that. So, and documentation, that's awesome. So, you know, so I think I'm excited about this. It's a nice big team. It means we might be able to build a really awesome product. And if we can do that really rapidly, and we can go, awesome, these guys have delivered, that's great. But if you guys really want to like have some big impact on what's happening around Australia, we can start reaching further. There's a lot we can do. So so let's see how far we get in the first, like, you know, little while. Now, how long time frame? How long have you guys got to deliver this? Okay, so we've got more or less 9 months.
Yeah.
9 months. Okay, so cool. All right, and I'm expecting you to give us timelines on what you're expecting to get done, and to manage that for your team, and to sort of, and you just say, look, we're really having trouble with this, or or this part we're progressing with, or Joel's not pulling his weight. Sorry, it's not getting done. So whatever that's your job.
Yeah,
okay?
that's my job.
So if there's any problems with the team, I want you to be telling us. And then that'll be with your help.
Yeah.
But also I want everybody, Christy's probably already done this with you guys. I don't know what she hasn't done, right? But just in terms of leading teams, you've all got to agree, right? He's the boss. Okay? Okay? And so then if it comes down to having an argument about something and you're not agreeing, or then it is his role to pull everyone up with him. And you can't get upset about it. So that's actually the role, okay? And then, he'll work with me on it, and I'll pull you up on it as well. But that's a key point, all right? So you've got to, now, in Australian culture, it'd be very kind of straightforward. But, you do it with your culture, and you do it the way that you want it. There's lots of different types of leadership. So that's your role.
I'll try my best.
Yeah, so that's what I'm expecting of everyone else as well. All right, you guys go through the questions.
Yeah. So the first one I want to ask you about is, could you give us a more detailed overview of your project? Because as we know in the last lecture, you have 3 projects that you have to talk about, and you didn't have much time, and not all of us had a chance to talk to you. So
Cool,
yeah.
that's fine.
Yeah.
All right, let's see if any of these pens work. All right, cool, good starting point. Doesn't rub off. Sweet, okay. All right, so we are, apologies, my handwriting is not great. We are the Climate Futures team, okay? And what our role is to take global climate model output, which has it's a grid of climate information, okay, that's really big. And for example, if Tasmania exists, there's like 4 grid cells that cover Tasmania. And what our team does is that means that, we know already, and you all would have experienced it, although you might not have thought about it, that it's warmer here than it is on the top of the mountain. And that's not very far. And if you look at the size of this grid cell, and it's saying that all of that area is one number. And if you take the average of all of this grid cell, okay, it's going to be at sea level because most of it's in the ocean. So it means that global climate information is not useful to Tasmania. And we do that. Tasmania is a good example. We do it for the whole of Australia as well. So what do? We turn this into a much, much finer grid. Okay? And that information is stored in a big data archive. At present, that data archive we use, it's basically just a directory, and we use a convention to understand where stuff is. So it's just a big directory. It's full of what's known as netcdf files. Okay. Have any of you heard of those before? No? That's fine. It's okay. You guys are programmers, you'll get it really quickly. Okay? I spend a lot of my time teaching people how to get out of Excel and start using the terminal or start using the programming language, so you guys are going to be fine. These netcdf files are multidimensional. It's important for understanding that, but let's move on let's just leave it that there's lots of stuff inside those. The directory is structured by file name. So the file name and the directory structure is the convention that everything's currently databased in, right? And this is a really standard technique for climate scientists because you can program path names and you can program file names really, really easily. You don't have to have a lot of special skills. You don't have to use a database network. You don't have to use all this stuff. So that's why we use that convention. And the file names are really long. So path structures are really long. And we can show you those. Probably most relevant for the programmers and documentation. So, you guys have to decide, like, each of your different tasks will have different questions. And so you're going to have to kind of liaise closely with the programmers, but possibly with the others as well. And the programmers, you all have to have different types of connections. All right, so this is the data we have. It's stored in a convention. Does everyone follow that? Pretty straightforward. Yep. And have you heard of this? Like, have they talked to you about this inside your course so far? Oh, okay. All right. So there are kind of 2 types of storing information. One is you have a directory structure, and the directory structure is like, let's say, you just got all these different path names, and then let's say, well, these are .nc files, right? So you might be like, okay, this one is, it'd be good if I could actually show you some, but let's say this is 10 kilometre resolution data. So each one of these grid cells is 10 by 10. And the next thing we have is that it's the grid that's over Tasmania. And then we might be saying we've got multiple models. I'll get to that. So then let's say this is model 1. And then we have variable names. Let's say that's temperature, which unfortunately looks a hell of a lot like a temporary file. Temperature, and then we have the full path name here, which might be like 10 kilometre underscore Tas underscore mod 1 underscore temp. Okay? And so then that's what a convention style looks like. database would store all of this information in a way that you can search for it, and then it would say, oh, I know where the file is, and it would then give you the full path name as an output from the database that just tells you where the file is. That's fun, right? So that's how we kind of navigate our space at the moment. What we want to do is to be able to take, I'm going to draw my poor picture of Tasmania, and I'm going to, let's say for example, I'm a wine grower, or the wine industry, and I am interested in this space here. Now I don't care about anything outside that space for lots of reasons that are relevant to them. So what they want is they want to be able to throw this shapefile at the data and extract just the bit they need. There are hundreds of variables, there are 6 models, there are particular domains that they care about. There's particular resolutions that they care about. And so over this space, they want to be able to say, give me all of the variables that I care about and summarize that up in some way. Now, the summarizing bit we'll discuss much later. We're not going to worry about, we're just going to worry about extracting the data and giving it to people at the moment. So, you've got this weird shape. These are usually defined as shape files. Has anybody heard of these before? Probably most important to the programmers to have heard this. Okay. So shapefiles are geospatial files. If you think about this what I've actually got on the page here. If you're going to draw that in a map, okay, you need to have latitude and longitude. And then if this happens through time, then you also need the time axis and how that changes through time. So we've got this 3-dimensional space at least. Okay. You could actually start saying it's multi-dimensional because we've got lots of variables. Yeah. We've also got height. So you've got latitude, longitude, we've actually got a Z dimension, which, let's say, it goes off like that. So height, which means that we've got multiple layers. Did any of you guys see my video?
Yeah, I see it.
You saw it? Yeah. So, let's see if I can do this. I don't think I can. No, I'm not a good enough drawer. But I can do it this way. Should get the artist done. So you've got to think that each one of these grids is actually a 3-dimensional box. Okay? And that 3-dimensional box has lots of 3-dimensional boxes through time because it changes at each time step. So that's what we've got. And NetCDF files store stuff like that. So you can kind of think about all the NetCDF files as being these 3-dimensional boxes, all kind of like stacked together in a sensible way. If we've got a weird shape like this, let's see if I can, actually a different colour will be helpful. So we've got a 3-dimensional shape that sits inside that box. The time axis is kind of like that. So let's try and draw that kind of reasonably. Okay, so the time axis can go through this way, right? If we're looking at a single layer, right? So we've just got a single layer here and then it moves backwards in time. And then we might go, all right, what we're actually interested in is the next layer up. So and so then the shape of Tasmania actually changes as you go higher. Yeah. So that the higher mountains of Tasmania might actually only be like that, and then they travel through time. Does that make sense?
Yeah.
Sweet. I can't believe that worked. You've got no idea how hard it is to explain this to some people. Alright, you guys obviously have similar minds. Well, this will be good. So, shapefile. How's the shapefile relevant? In this one here, you only want to extract that bit. Okay? So you're trying to say, go in here, only find those cells, pull that out.
That is shape files.
So the shape
So
files.
blue area.
Yeah, the blue area is the shape file. Yeah. And so these files are geospatial files that basically say for this latitude, longitude, height, it doesn't have a time dimension, extract this stuff. Okay? So we have to make these files and those files talk together. We've got the code that can work on that bit. We understand how that works and we can teach that to you guys to make that work. Okay? What we don't have is an interface that makes sense. So that somebody can say, this is what I care about, this is what I want to do. Now, some of these interfaces do exist. So one of the first tasks I'd like you guys to do is actually come back and say, here's all the interfaces we've found. Here are the ones that we think are relevant. They might be for different industries, they might be for different data. But here's some cool ones. It's one of the first jobs I want you guys to be able to do, so you kind of start to understand what interfaces are out there. You might decide that you don't have enough information to do that yet. We need to have a few educational sessions to get you guys up to speed, and you can go, aha, yeah, I know what I have to go find now. Okay, so that's kind of, I think I've leapt ahead. So we've got data in directories. The data is multidimensional. We want to extract it using this. Now, there's lots of tools already that can say, oh, well, if that's your shapefile, then really all you need is that rectangle that contains the shape that you care about. And pulling out the rectangle, there are heaps of tools that do that already. That might be useful to you guys. You might be like, oh, well, we'll use the rectangle first, then we'll do the hard bit. Yeah. Right? But this is where I want you guys to come up with some solutions, or see if the solution we've got already is actually it's actually the best thing available and no one's doing anything close to it. We'll just put a fancy front end on it so that people can interact with it better and put it into a language that's transferable and stuff, because it's currently running in R, and R is not necessarily going to be transferable in the same way that other stuff is. It's our personal tool. So this is where we want to try and figure out what will work best. Now, databases. Have any of you built a database before? You have? Hands up. Okay, cool. So one of the problems we've had is we tried to build a database to capture all of this information, right? Because we wanted to be able to say, well, if you're in this particular grid cell, then here you are. So that we could give it a question like this, a latitude, longitude question, and it would then be able to go off and find everything. But what we found is that because we also care about where you are in time, so you actually care about, I want to get this grid cell, and then I want it to move, and I want to get this grid cell, and then I want it to move up here and get this grid cell. So if I could think about building like a tunnel, think about it if an animal moves through space, right? If an animal moves through space, and nobody's done this, so it'd be cool if we could build it, right? If an animal moves through space, then that means that at this moment they're here, but at the next moment they've moved into another grid cell, and you want to try and track. And we have the tracking information, but that means that we need to actually reference every cell inside the entire grid through space and time. And when we built the database was as big as the data itself. Now that's possibly just because we're crap at building databases. We don't know what we're doing, and we absolutely do not know what we're doing in that space. So it might be that the convention is actually the best way to store most of the data, and then you do a secondary step, which is time and space somewhere else. So this is where I want you guys can be creative. You guys can come up with other people have done. You guys might be looking at this problem. It's like, yeah, I totally know how to solve that problem, and that would be great. Right? That's fun. So that's kind of like the hardest thing of if you've got an animal tracking data and you want to try and track things through space like that and pull out like this moving tunnel of data. So that's like where we'll try and get to eventually. The first thing I want is basically a system that you can pull out the rectangle. Then we want it to be the shapefile. Then we want it to be the animal tracking data. Okay. And then obviously each one of those steps will require different inputs from the user. Now it could be that we just give them completely different, they require different interfaces. Like as we go through this, it's like it's not the same question. You know, if you've got animal tracking data, you need all of these tools. But if you only care about a rectangle, you need this tool, and that's it. So this is where we will find the optimal solution, and we'll also find the achievable solution. And that's the other part, right? I'm acutely aware of you guys have to have this finished in 9 months. We want to have lots of little wins early on, build something, make it look as pretty as possible, make it so it's really easy to understand, then move on to the hard bit. And we might go, oh, we actually have to rebuild everything. We'll hopefully be smart enough to go, here's the workflow, we can build this bit, and it's going to be easy to build onto it. That would be ideal, but you guys are programmers, you guys have done this before. You often get thrown a different question, it's like, shit, I have to build it from the beginning again. So, alright. Does that kind of sound like something that makes sense? Do you understand what it is I'm asking? Have I answered all of the various questions? Is anyone confused about this bit?
Still a lot of questions we have on a document that we made. Would you like to see that directory structure
Yep.
as soon as possible?
Yep, I can give you guys access.
That's really complicated things. We thought it was just an SQL database.
No, that's part of the thing that we actually want you guys to solve.
Yeah.
Is it so? So a lot of the directory structure would easily translate directly into SQL easily. So basically, all this bit, even the file name, easily SQL.
Yeah.
It's only when you start trying to do these bits that it gets a little bit more complicated, and that's where understanding some of the NetCDF tools that exist and how they interact. And there are NetCDF compatible databases.
Yeah.
Threads, Ramada, there's a couple others. We haven't built them for our system yet. We really need to build one for our system. We're actually supposed to have all the data easily searchable and stuff already. It doesn't exist. So an SQL is one solution, but there are other solutions.
Yeah.
And this is what I'm kind of, I don't mind if we have to use one of the SQL solutions. However, I suspect there's a lot of out-of-the-box tools that you guys could learn how to interact with. Okay.
Yeah, I just want to let you know that we expected SQL curveball. Now there's a lot of extra work we got to find.
Yeah. Yep.
But
Okay.
it's okay. We'll get it.
So, yep, that's cool. And also, after this meeting, like, if you guys are like, well, I'm just not sure, like, especially after you go off and find out how all the NetCDF stuff works, if you guys are like, oh man, this is just going to be so hard. Now, I don't think it will. Like, you know, I was able to do this, okay? I'm able to read documentation and learn how to do it. And there's a couple of particular cognitive sort of understanding things that once you kind of get it, it's like, oh, okay. And I can help you with that. Just don't, if you're struggling with understanding something, get in contact with me, get a group of questions together, Kim can send them through. We can either organise a training session with me and Pete, or I can just answer the questions over email. So if there's a curveball, that's cool, but let's not see it as a limitation.
Yeah, no,
There are very few people that know how to do this stuff. It's actually going to be a really valuable skill for you guys to be able to say, I understand NetCDF, I understand how to do big data, I understand how to do this. Like look at the project we've built. Look how pretty it is. So that's where that is. All right. So that's good to know.
Yeah.
Thank
you.
you.
I just wanted to let you know.
Yeah, that's great.
We have to learn. Yeah.
Anything else?
Yeah. Oh, yeah. Sure, go
Is it
ahead.
just Australian data?
Yes.
Just on
We've actually got all the data in hand sitting with us.
yeah, but our data is only in Australia. There's no American, Asian data.
Well, there is a global data set, so there is data that is global in scope.
Yeah.
But it's all sitting on our server.
Yeah.
And it's about us being able to feed that out.
Yeah, for sure.
So
And is there set stations that just get all this data like every hour? Is that where all the data comes from?
no, the data is actually static.
Yeah.
So it's not about managing constant inputs, although there will be one data archive that may grow. Let's not worry about that just yet, because just assume the data is static.
Yep.
And let's say it had to be updated every quarter. Okay. So it's more of a we update stuff and then we run a script which would say update the database or something. It's not. It doesn't have to be real time.
Yeah.
So, which of course simplifies things enormously.
Yeah.
The optimization of that process can, it can take 2 days to run. It should never have to take that long. but that in terms of that's not where the effort should be going.
Yeah.
Yeah. Unless you guys are really into it, and then it's like, yeah, sure, go for it. Yeah.
Yeah.
So I'm just, before we move on,
Yeah.
is there anybody that has any questions about that? Just in what I've discussed so far? Does it kind of seem clear as to what it is I kind of want? And we can show details. That's fine. I'll give you guys logins. You'll be able to see what's there. Yeah? Cool.
Yeah, so I believe that presentation has pretty much answered a few of the questions that I have below this one.
Oh, sorry, I have one other thing I have forgotten to mention, which
Yeah.
is pretty critical,
Yeah.
pretty important. This is all running on a Linux system. Who here knows Linux? Okay, that's cool. Yep, alright, you've got 3, that's fine. No. Okay, alright. That's cool.
So Ubuntu.
Yeah.
Cool. On the Nextcloud.
Yeah.
Yeah.
Sweet, awesome. We've just covered off a whole bunch of training. Awesome. Okay, so that's the other important part. Now, for you guys that aren't familiar with it, have a chat to these guys, find out what it is you need to know. They'll be able to get you up there. If you already know how to work on a command line, you'll be able to pick up. It's just a series of different commands. A lot of them actually are the same. So, all right, cool. Next question.
The next question I want to ask is about the targeted end users.
Mhm.
Like, should we build an interface for generic users, like everybody can look at the interface and know what they have to input in and get out the information, or we specify in building an interface for experts with a lot more of unexplained things, like they know what they want to do already, we just pull out the stuff.
I think the way to think about that is that the minimum viable product, right, is the first thing of let's build a database that my team can use, right, and it streamlines our workflow. And then we start stepping it forward from there, going, okay, what are the things that actually somebody who knows nothing would need to know? And there will be a balance at some point. So at some point it's you're trying to extract global climate data, climate model outputs to use in a scientific process of some kind. You've got to understand something, right? So there is a certain balance there. However, one of the crucial problems that we have, and I think I mentioned it in the talk, is that people say, oh yeah, can you please give me all your data? I'll put it into my Excel spreadsheet. It's 150 terabytes, where are you going to put it, and how's Excel going to handle that? So a lot of the questions do come from very naive people who don't actually understand what they're doing, and therefore the system needs to summarize that down. There are many tools that exist that we can implement that can do this. So, and talk to the programmers about those tools at the appropriate moments or as you guys get excited. So, but the first step is like, can we build that database that we can use? So that's expert users, relatively straightforward. It also, there's nationally, that would help us share our data with another sort of 50 odd people, actually, probably a bit less. But that kind of scope in terms of like community. The next scope of community is like, tens of thousands. So let's say 10,000 people is like the next one out. Almost like it's going to be delivering to insurance agencies, banks, it's going to be delivering to researchers. They all kind of sit in that next zone out where they care, they want to get the data, they don't really know what they want or what they're doing, they need a lot of help. And so there's a very big gap between expert users like myself and the next people. So there's a lot of thought to go into that, which is why I don't want to commit to that just yet. I think let's make sure you build something where we can, and it is complicated, and you are meant to know stuff, and we'll put in as many like little, you hover over something and a little example pops up that is possible without it getting in the way. Like I find it happens all the time. I can't remember which I think it's Excel. You hover over something and it's like, get out of my way, I'm trying to do work. so we just need to, I think there's lots of there's lots of things where it's like, if a bubble's going to pop up, it doesn't cover another button, like it's easy for us to just build stuff so that, there's actually like a whole help section where if you hover over it, it automatically updates something. So there's lots of little things like that I'm really excited about being able to build. There's lots of tools. We could even build the documentation. We could even build an entire course that people have to go through, right? And have you guys heard of software carpentry? No. So software carpentry has basically its whole idea is about teaching scientists who can't program how to program. So, because if you think you're going through an ICT course, a lot of people have gone through a science course who are understanding science, biology, physics. They're not getting taught how computers work. They're not getting taught how to code. So, and that is changing. They're building it in, but anyway, it's very slow. So, software carpentry has identified this problem and said, well, actually, here's the basics of Bash, which actually all of you guys should probably look at. Here's the basics of Git. Here's the basics of SQL. Here's the basics of R and Python. So, and in that process, they've actually got, here is how you deliver an online lesson. And it's in Git, and you can download it, and you can edit it, and you can start uploading all your own stuff to it. So for documentation, it'd be perfect. You can step people through it. It's online. You could actually even take them to the website. So there's lots of cool stuff you could do, which would be pretty awesome. And so it's just a matter of, we can go for, have you used LaTeX? Heard of it? Has anyone heard of it? Okay, so LaTeX is like Word, except it's programmable. It's heaps better. So I've produced a 480-page document full of figures and text automatically using LaTeX. So it's the first thing I use to learn how to program, which tells you a little bit about how hard it is to use. It's a markup language, so it's like, it's super easy. So it's basically like writing an HTML.
Is that another one that's written like latex?
Yes.
Yeah.
Yes.
Okay. Yeah.
Latex. Yes. Latex is the other. But because it's developed by a German guy, the way we pronounce it is using the Latin, and so the X is pronounced as Chi from Latin. It's like, yeah, it's so fucking nerdy. It's ridiculous. So, all right. Sorry. Apologies for my language, but if you guys don't mind, I will continue. So.
So I think that pretty much answered a lot of our questions we had in mind previously. Talking to you, we know that the application is going to be really complicated. We were planning to ask for any additional app functions that you want us to program into. But I think this is complicated enough, so I'll just skip that part. You guys.
Yeah, and I think it's really in that context. Yeah. I think it's really about. Let's see how far we get.
Yeah.
Work as much as you can as a team on getting the first bit done, understanding the various different programs that are available to use. I'll give you a list of things that I want you to go look for and understand, and then I'm kind of excited about what you guys might be able to find that's outside of my scope of what I know is there. I think there's a lot of kind of like out of the box things that you could apply in the first instance, which might be like, oh my god, this is so scary, and then you look at it, it's like, oh, we like install, hit go, you know, select directories, finished. Great. Okay, now what? And so in that context, it's like, let's get through the bit that is scary for you guys. It's all new, all that kind of stuff. Make it work. Make sure it's, you know, robust enough. We don't have to worry about scalability and stuff of the website just yet. Let's worry about just making it work for our team. Then we'll say, all right, if we wanted it to be 50 people, what would that look like? And if we wanted it to be 10,000 people hitting it up at a time, what would that look like? And where would it have to be hosted? So we'll worry about those components of the design later. Web design and kind of, any of you guys aware of? Yeah. Okay. So we've got some skills there, which is, you know, it's crucial because I don't have them, right? So that's all right. So
so the next bit that we are going to ask about is pretty much technical inquiries. Are the team? Yeah.
I think there's a few trivial inquiries that we wrote down that we still have to get for the initiation report,
Restrictions, right?
like what hardships and things like that.
Yeah.
So the reason you want this project is because I think from the lecture you mentioned, people will email you for your data.
Yeah.
That's just obviously an awful way to do it because it's not automated at all. It takes time out of your day. We just wanted to get the motivations for the project in our report, like what bullshit you have to put up with that makes you like, okay, I'm going to go ask the students to go make this because I'm sick of doing this. Like, we just get some more details about that.
So I guess the biggest part. So you actually covered off on a few of them, and we've kind of got to them.
Yeah.
People need this data. It's really important for making business decisions, particularly over the last 2 years. There's been a real kind of shift. People really want to know this. So people need this data. People don't necessarily know, and then people don't know how to interact with it. Yeah. Think about how much you understand what that means. That's where they're at. Okay. So at best, have any of you heard? I know you don't know geospatial. So ArcGIS is an output that they'll want to have it for. So this is just file format stuff, right? It's like sort of asking, can you give it to me in a CSV file versus something else? It's like there are tools for it. That kind of element is easy, but some of these people are actually quite sophisticated users of data. They're just not familiar with this, and they're not familiar with the intensity of this data in terms of how many layers there are, all that kind of stuff. So a motivation is for us to build in, and this is where as I was talking about, I was really excited about maybe even building a little course for the documentation. To really kind of draw out what people need. So what's the bullshit that I have to handle? People don't know what they need, so it actually takes me a long time to talk to them about what it is they actually need. So I'm hoping that as we go through this, a lot of the documentation will be able to kind of ask them questions that allows, you know, I've got a whiteboard, I should use it, that basically like allows them to figure out where it is they need to go and then what options they need as a result of it. So I'm hoping that there's what kind of question you're trying to answer, okay, and then we've like ones at spatial scale, so do you want global, do you want
like a guideline.
Well, it's actually more, it's guidance. Guidance, yeah. So it actually steps them through their own decision-making process. And so then we can actually get a lot of, first of all, to get them to think about it. Yeah. So a lot of people are like, oh, give me all your data. And it's like, well, actually, you only want 1 point off the top of Mount Kosciuszko. Like, that's a time series, and that's one of the questions, right? So it might be like, oh, we want global data, but yeah, we only want it for 30-year time periods. So we want to actually take all of this for 30 years, take an average, compress it down into one layer. So that's a different way of looking at data than saying, I want a single point, but I want hourly time steps for 100 years. So that's one thing I want this project to get into, because if you're going to extract data, you need to know what you want. And so I kind of want that to be built in some way. And I think that's why I think the software carpentry would be a really good example of how you could ask people questions and provide, and kind of take them down it's like a choose your own adventure, right? It's just a boring one. And so there's that. So that bit takes a lot of time, and I think that's the biggest thing. For expert users, it's also it's tricky for us to actually give them access to the data, because I can't just say to them, here it is on this server, and I'd have to set them up with a user account so they can like SCP in or rsync or whatever. And so I'd prefer it if I could say to them, yep, it's available through here, you can download it here. And I guess another part of it is like, actually, let's just leave it at that. For expert users, like it's actually a bit of a pain for me to actually have to set them up. There's a lot of manual steps, whereas it'd be nice if, and this is like, your user management is, I guess, if we could do it in a way that requires zero user management, so they just have access. This data doesn't have to be behind any firewalls. Well, it doesn't have to be behind anything special. It just needs to be generally accessible. If they want to then download it, they can. So FTP.
I think having publicly available climate data is a great thing, just for everyone to look at.
And it's supposed to be.
It's supposed to be.
And it could be that like part of this project is about figuring out how to actually publish this data in a more appropriate location. But I think even then we still need to have this tool for our team to use anyway. So I think we'll build it as if it's an in-house thing on Nectar that somehow has a publicly facing face, and that'll get rid of a lot of the internal inquiries we get from UTAS. So my brain's just kind of going through all the use cases and trying to figure out what I need to tell you now and what I can tell you in a month's time. So, but I think that's the short answer.
That's good, because there's many things to write down in this report we've got.
Yeah.
And one of them is what you have to put up with, and that's your motivation to get it, basically. And you said that people just don't know what they want, and we wouldn't have thought of that because we don't have to deal with it. So that's a great thing that we can write about.
Yep.
Thanks for that.
Yep. And so, and in some ways, it's really good. Your lack of experience in what I'm doing is a benefit that you should use.
Yeah.
Because any question you have to ask is a question that the people that we're engaging with are asking themselves. So write them down. So for documentation, just everything you don't know, write the question, and then we'll put in the answer in the documentation. So it's and use your team. It's not just your job. Any questions that they come up with, just put it down. We can answer it in the documentation. Like a lot of it's like a sentence. So so I think that'd be good.
Yeah, I think that covers all the trivial questions, right, guys?
There's one about nice to have functions.
Yeah.
Would you say that like that animal path thing? Would that be a nice to have?
Oh yeah, totally.
Yeah.
Like we'd be able to publish that as a paper.
Yeah.
It's so novel.
Yeah.
Nobody's done it before. And so, so there's some really cool stuff we'll get out of this. I think actually even just the database itself is a publishable paper that I'd like to have all of you on as authors if we go down that road. You guys, I guess that's a question to ask you. Are you happy to be authors on academic papers if something comes out of this?
Yeah.
Yeah.
Great.
Absolutely.
So that's what we'd be doing. If this, I mean, it's going to work, right? We're going to build something, right? And I don't think we're going to have any problems with that. So, and then once we build it, it will be a publishable item to tell the rest of the community that this exists. So so that's coming out of this as well. So, we might even get you guys to write it, and we'll see how that goes. Because all the documentation will be written already, right? So okay.
So we also have a set of questions that we aim to ask the TPAC team about
Yes.
technical issues, but I think it's okay for us to ask Thomas also. So there's like a lot of questions here. I think it would be like more convenient for the programming team and design team to ask these questions. Is that alright for you guys? Because there are like a lot of technical stuff here that you guys might want to add more into the questions. So
so it's just like we're going to be using Nectar Cloud, so we'll need an account or something on there.
Yep.
Preferably one that isn't connected to our UTAS accounts, so we can all log in. Is that possible?
So the way Nectar works.
I've used it before, and I had to use my UTAS account.
Yep.
Yeah, but is it possible to get one that isn't connected to anyone's UTAS account, so we can all share that Nectar instance
You can all share the Nectar instance regardless.
with just using like logins?
Yes.
Yeah. Okay.
Yes.
Yeah.
So-
But only one person be able to access the Nectar management.
No, we can put lots of people on there.
Oh, you can do that.
Yeah.
Cool. Okay.
Yeah.
That'd be great.
I think in the scope, it was you three that were familiar, like vaguely familiar with, like you understand Linux, you've used it, and you kind of know what it is. Is that a good way of thinking it through? So really then you only need you three, and then even then the Nectar Cloud actually doesn't really need you to understand Linux to log into the dashboard. But I think it would be really useful to have all three of you to understand like how to set up an allocation, how to go through all that. You just need someone to actually champion it for you, right? And that's me. The TPAC team want to build this system. It's on their jobs list, but they haven't got to it. So they will be like, oh cool, we've got a team of 7 people to help us. It's slick. So they'll be able to give you time to help with that. And we'll be able to get this its own allocation, its own setup, its own resources of RAM and storage and all that kind of stuff. So we'll be able to do all of that. To give you a sense of, let's see if I can draw this, how our team currently uses the data. Did any of you need to take a photo of that? Yeah, we can. Yeah.
Thank you.
All right.
All right, thank you.
Okay. Now, for the benefit of everybody else, because I suspect Joel might be familiar with this. No, it's not quite. Yeah, let's do that. So, there's something called the Australian Research Data Commons. Okay, Australian Research Data Commons. And what that is it's access to a host of things okay, so 3 of them that I'm aware of that I use all the time is CloudStor, Nectar, and RDSI. Joel obviously knows about Nectar. Do the rest of you know about Nectar? Do you know what it is?
I've heard of it.
You've heard of it? Okay. So for those that haven't heard of it, Nectar is basically cloud computing. So it's more or less trying to get you off your laptop and into the cloud. The biggest reason for this is because researchers have a lot of jobs. They just want to have, I need that process to run for the next 3 days. Just takes a long time. If you can do it in Nectar, then you can shut your computer off. You don't have to have it plugged into the wall. You don't have to have it like sitting there doing this thing, and you can't do anything else. So it's just about getting people to think about how they can do computing in a different way. That's what Nectar's core role is. Now, it can get some pretty powerful machines. You can get and you can also build it so that you can farm off jobs. So Nectar is all about log in, I need this job, I need it to work for the next let's say 3 weeks. I need 3 weeks of compute, I need 100 computers, each of them have 4 gigabytes of RAM, and I'll farm out all my jobs to 100 computers. That's one use case. Another use case is we have a team of people that really want to have access to a big data archive, which is research data storage infrastructure. This archive is 150 terabytes. And the Nectar instance is our compute that's attached to that. So Nectar is our compute. I don't know, you guys probably have a symbol for this in computing. I don't know. So we've got our compute. And so what this is our compute gets connected to the storage directly there. Now we can have multiple separate computes connected to the same storage. And so you can have lots of different people accessing that. We can also access everybody else's storage. So when the astronomers have a whole bunch of data they've put in, we need access to it. We can access it through here, through our compute system. So the Australian Research Data Commons has that. So the research data storage infrastructure is where our data sits. We have a Nectar instance, which is our compute. I think our one is 64 gig of RAM and a terabyte of storage. It's fairly modest because a lot of the stuff you can do elsewhere. We also have HPC, high performance computing. So this is where you have big racks of compute. Heaps of it sitting there, thousands of CPUs. And you can you can connect this to your data as well. This is separate to your Nectar Cloud. So you do your really big jobs here. You can log into it from your Nectar Cloud and drive stuff, but you do your big jobs here, it stores the data here. It might actually use the data and then create new data. There's lots of other stuff, but that's the system. So you've got the system we work in. Now the Nectar Cloud, I'll do the closer one, allows lots of different people to log in remotely to the same system, which means we only have to, so our team, we've got 12 people that are currently users, they all log into the same system, I only have to manage one computer, everybody's using the same tools. It also means that we can share data, that's the other part. So there's the big storage, and then there's little storage. Let's do it as that. So then, this is where we store all of our scripts. So the compute itself is separate to where we store all of our scripts, all of our figures, all the stuff that we actually have to save that backs up our academic journals. That all gets stored here. So that then if this breaks, this is a cool thing about Nectar, if this breaks, we haven't lost anything, we just connect it to somewhere else. And everybody can keep working. Okay? And this system here can be backed up, so we know all the configuration that we did on our server. So we're in the setup. Do you think that's a good enough explanation, Joel?
Yeah.
Okay. So the question was about kind of this part, okay? So the Nectar install will be how you manage multiple users accessing the same location. Well, that's how. It's going to be in a system that explicitly is there for sharing. And I'd strongly recommend that you go in and also start using some kind of version control software straight away. So,
And if we use GitHub, if it's public,
Yeah.
that's fine.
yeah,
Okay, cool.
we use GitHub.
Yeah, great.
So, which will allow us to go in and have a look and stuff too. So,
Because it's free.
yeah, that's it. Yeah, all about free, all about open source. So it'll be interesting. I will give you a task of going off and find stuff at the end of this, but I am interested in understanding if there are paid solutions available. However, we're not going to use them. But it'd be just interesting if in your research, when you go off and find stuff, if it's a paid resource, just write it down and just be nice to have a list.
Yeah. Yeah, do you want me to read the next one?
Oh, yeah, sure.
Yeah. If you want to, it's alright also. So yeah. And the second question is, we only require read permission for the climate database. Can we please have some login credentials for the database?
Yeah, that'd be great.
Yeah. So once we set up the Nectar install, then that'll be connected with read-only to the data.
Yeah. So
And-
we need to check that out.
That's right. No, that's exactly the point. It's about building this so that it's like that. Yeah, that's immutable.
Yeah.
And then we build a whole nother section that can crash and burn. Yeah. You know, and it might be you guys set it up and you do some work and you're like, oh shit, we really just broke it. Oh well. And if you just build the system so that you can just like hit go and it'll just rebuild a whole new system, then yeah, fail fast. You know, like that's fine. It's not an operational system that we care about, and even if we start using it, we are quite happy for you guys for it to fail fast. So.
And yeah, the next one is there any like website template that we should adhere to for them to be consistent with the UTAS design?
Oh, do not worry about that at all. Okay. Yeah. So there are so many reasons not to follow the UTAS website.
One little like shit.
So no, I think no, make it look really pretty. Make it follow whatever the best templates and formats are in terms of like web. I have absolutely no idea what languages are the most appropriate online, all that kind of stuff. If you guys like, now we should. I'm going to even get this wrong, right? I don't even know what they're called. So you know, if you guys are like, oh no, we really want to program this in Ruby, or we really want to do it in whatever your favorite language is, go for it. Because I whatever's going to be the most efficient for you guys, and as long as there's really good documentation. I know one of our team loves using Ruby. I don't actually know what Ruby basically does any differently to the other languages available. I guess one thing is we use R, so it'd be really useful if it can integrate with that. But we also use Bash, CDO, Python, SQL occasionally, C. You know, we don't really care. I mean, you know, learning your first language is hard. Learning the second one teaches you how languages work. So you know, we don't really care about that.
Coding is less. And maybe you care about security. So what about security?
Now, that is something I'm hoping you guys know more about than we do, because of it's. I'm pretty sure it's one of the units you guys have studied, and at least, and so there will be. So Nectar has a number of rules. I am not really familiar with what they are. One of the reasons that these things get burnt, like get shut down and terminated, is because there's security breaches. So if you build this with the understanding that if there's a security breach, then the Nectar guys will just terminate your instance, because that's the whole point. So then build it so that it is scriptable. So you can script up the entire launching of a Nectar instance. I'd start there. So just start from a scriptable version, and that means if something breaks, you always got exactly where you got to sitting in your script. Obviously, the script is going to be tiny compared to like the actual install, so it's super easy to save that in a GitHub Git account and just, oh yeah, something broke, shit, we lost yesterday's work. Oh well, we didn't lose the other 3 months. So I'd recommend talking to the Nectar team about that, and then talking to the Nectar team about what's the best way to set up security. So they do have some protocols they want to implement. Best practice is, of course, what we're after. Actually, ideal practice is what we're after for this, because best practice lags behind ideal practice, and it'll make it sort of long-term more stable if you guys aim for like what's the most we have to implement, and it'd be really useful for you guys as a team to talk to them about what actually is required, and understanding why and what the vulnerabilities are of this system. There's a little bit of security by obscurity in this space, but it's worthwhile talking to the Nectar team explicitly. They can tell you a lot more than I can. But I'm very worried. I'm very interested in it, and it might be one of the things that actually kind of requires a bit more effort, simply because I don't actually know what the solutions are. So, but the Nectar system is designed for this. So there are solutions that exist. It's just I don't know what they are.
Yeah. So we should be like contacting the Tibak team about this one, right? I'm aware that they have an office.
Oh yeah, I'll be putting you in touch with Yost.
Yeah.
Yes. Yost will love to talk to you guys.
Yeah.
And we'll be able to take you through a lot of the initial things. I mean, there's even a database, a portal for downloading data that they've already set up through IMOS and IMAS. So there is an existing framework, and it's one of the things that you guys should find. Well, I'm going to give you the list, right? So there's a lot of stuff that it might be like, all right, we just have to implement this, and then we actually can make that better. Would actually be a really great outcome as well. So, and learning about how to implement those things, how to make it look prettier, how to document it better, like all these things just for our team, it might decrease the barrier to getting to that minimal viable product as quickly as possible. So there's lots and lots of options out there. I do not expect you to build anything from scratch, right? Like, this is programming. You should be copying everybody else's stuff as much as possible, right? So we just want to copy the best ones. So, yeah.
Yes. So the next thing I want to ask is what extraction file formats that we should make available, like Excel, CSV, that type of stuff.
Oh, okay. So the file formats will typically be NetCDF, GeoTIFF, ASCII, and there'll be a handful of others. There are tools, I think there are tools that output these already. CSV, maybe. I mean, there's as I said, like if you've got this grid, you don't want that in CSV. Like, it's not actually useful because it doesn't describe the data enough. So this is complicated data. It needs to come with the information about it, and there might be a little bit of. So ASCII is probably the closest to CSV because it's a grid, and it comes out and the position in the grid actually tells you where it is. ASCII files have a defined format of what needs to be in the header. We need to figure out if we can add more headers because there's never enough information in an ASCII file. But all of that, it's super easy just writing out a file. It's like, to take one person a couple of days at most to just get that right. But there's a lot of jobs that'll add up of a couple of days at most, and it's all of a sudden you've got 9 months of 7 people working, right? So those, a lot of the tools like Ramada and stuff have all these things inbuilt, and they understand what the data is that's an input, and so I don't think that's necessarily going to be important now. It's we could actually say, let's make this work just so it outputs NetCDF files, and then after that we go, all right, here are all the file formats that are actually reasonable given the data type. Yeah. So if it's a time series, then CSV is fine.
Yeah.
it's like it actually makes perfect sense. But if it's not a time series, then it actually starts to get really complicated very quickly. So
Wondering, there's 100 terabytes of these NetCDF files.
Yeah.
How big is the typical just one of them?
So there's a couple of files that are about 90 gigabytes. However, those files are hourly time steps of 25 vertical layers across a relatively high resolution spatial grid, and there's only a handful of those.
Yeah.
And we wouldn't, I mean, the system needs to be able to deliver it. That probably comes back to one of your earlier questions. What is what are the bullshit things you have to manage? Yeah, the hardships, exactly. That's the better way of putting it, isn't it? So the hardships are that if somebody wants to download this data, we need the tool to be able to say, you have requested this much data, so that they actually realise before they download it that here is the estimate of how much data you have actually.
Yeah, we'd already thought of that. Yeah.
And so the easiest way to do that is to basically catalogue when you build the database on where all the files are, to then also extract the data size, store that, and then when people request, sum that up. Because as far as I'm aware, I've asked this question of everyone for a long time when I'm using external databases. Please tell me how much I'm going to download before I hit go, so I know how long it'll take. And how long it'll take is actually that's harder. But if you know that it's going to be a terabyte download, you know it's going to take longer than if it was a megabyte. So but also you need to have the place to put it, and you need to know what that request is. So the Bureau of Meteorology have like a system that says you try and select something to download, and it says, sorry, your request is too large. It doesn't tell you how much too large. It doesn't tell you like anything useful. You just have to like slowly decrease the size of your request until it works. It's real, yeah. As opposed to saying, oh, your request will be broken up into 15 different requests so that they're a reasonable size. You know, so this system must have that. That's a must. So some of the files up to 90 gigabytes, and everything else is smaller than that. Most of them are about a gigabyte, maybe two.
I think we'll be needing a negative instance of the log RAM.
Yeah. Certainly for you guys to prototype.
Yeah.
And then once we've figured out what it actually is and how much,
Actually,
what we're actually doing on the system, then we'll be able to optimize that as like the last step. So, because Nectar you can like crash and burn it and restart it with different amounts of resources. So that's why it's awesome. We don't need to buy one computer and that's all we've got. It's like, oh no, we need to have 64 gig of RAM's not enough. Let's try 256. Off we go. So, yeah. So, yeah.
So as you mentioned before, I believe this is like a public portal for everyone to download.
Yeah.
So yeah, should we have like a capture functionality to prevent bot spamming for like people just downloading everything like for an internally long time?
So that the download step before you download, just a simple, the capture that you
Yep.
enter. Yeah, because
Yeah,
it's easy like a
verification
script
step.
to just spam that download button with a really large data set. All of a sudden that computer's crashed. So if it's just a capture there, it takes 2 seconds for someone to enter.
So I guess,
So this might be a last step. This was like a nice
so,
to have.
so the short answer is yes, that's what we want.
Yeah.
The longer answer is, ideally, if somebody wants to download everything, I want to give them the capacity to do that.
Yeah.
But I don't want it to be using that clunky shit method. I want it to be a standalone, like, you want everything, great, here it is, set up an rsync, off you go. So it's really about building something into the system. And that might be as simple as if you want all this data, contact something. You know, contact inquiries at UTAS. Whatever. And this is where I'm hoping you guys will be able to have the understanding of here's actually the appropriate way that you would do this. Now, a lot of the stuff that I'm asking all sounds really sensible and easy, right? But if you go out and have a look at databases, a lot of this information isn't there. And that's what I want you guys to do is in your researching over the next week. It's each of you to go out individually, and I think it's important, individually to find whatever you can find. And then, just before our next meeting, come back, consolidate everything you found, because doing this work individually is really helpful for each one of you to actually go down different rabbit holes and find different solutions, and then come back and then you'll have a better consolidated list together. So, and I'll give you a whole bunch of starting points, but I'm interested to see how far you can get. And it would be useful too to go through this list and say, well, how many of these things that you go to have what kind of functionality, a bit of, brief kind of functionality kind of tick list, and you guys might be able to come up with that together, and you kind of covered a few of them yourselves here in that list there. But I think these things don't exist in a lot of other databases, and I think the capture is really good because it's we don't want people are using that method of downloading data. It's a really crap way. It's no, use FTP, use
mostly to prevent an attack. Yeah, not someone who's genuinely trying to get it, but someone who could write a script to spam with a lot of requests, puts the computer under stress, and then it can't serve legitimate users.
Oh, okay.
Yeah,
right.
because if there was no capture, then a bot can easily just download it a million times. Yeah.
So yes, so and this is what I'm hoping maybe the TPAP guys can teach you about some of the potential options.
Yep.
So capture's one of them. There might be a whole bunch of others that they I think they've already got systems I think our Nectar server gets hit by bots a million times a day.
Yeah, probably.
And they just have systems where it's once they've been hit by something in 100 times in 10 seconds or something, they just block that user.
Well, they probably do have to.
So there's a whole bunch of stuff that, yes, I'm hoping that is covered in the security module of your work, and more or less we are supportive of that. You tell us what we should be doing, not necessarily waiting for us to ask for it. Does that sound reasonable?
Yeah.
So one of the questions is, should there be a limit of data that someone be extracted? I think that answer is no.
There should be a limit. However, I'm not sure what the limit should be.
Yeah.
But let's wait until we actually have a system that can count how much data is being downloaded, and then we have a discussion about, well, what do we think is reasonable?
Yeah, and anything about that contact.
Well, it might just be we've got those different pathways that people need, right? So if you're going down a pathway and you want time series data, and you ask for 10,000 time series, then we should be no, go and do this one. You actually need this type of data delivery, not that type. So that they're forced, I'm quite hard-nosed like this, they're forced to actually learn the skills they need to do their job. So I think, I don't want any researcher to say, I had to do 10,000 entries into Excel. I can't. Anyway, there's a whole bunch of stuff like that. So I think there should be limits, but it really depends on exactly how sophisticated our delivery gets as to what we think the limits should be for particular data types and for particular data pathways. So, we should actually, in that pathways, we should be saying how many locations are you downloading? And you say, if it's greater than X, if it's greater than 10, you really should consider a spatial approach rather than an individual file approach. and then we might say, look, if it's greater than 10, have you considered this? They say yes. We let them go to 20, and then we're like, sorry, after this, you definitely we're not serving you this way. So there's that, and that could just be even before they start downloading stuff.
Yeah.
It's like just through their pathway, and it could be like put in the lat longs that you are interested in into a table that where they put in the values themselves, and when they say they want another 10, like they want more than 10, we say more rows, and then the last row is like you really shouldn't do it this way. Like something like this that sort of says a different approach. So I think if we kind of build it in like that, it's really about user interface rather than actually. I think we can control a lot of it through the user interface and know what it is we're expecting those people to want.
Yeah.
Yeah,
we're really interested in making a user interface that is dead simple, but also can teach you. Yeah.
We're not. It's never going to be dead simple because this is not a simple thing that we're doing. However, we can make this the best interface to download climate information that everyone's ever seen, and it's really easy to do it. The expertise that you guys have had in training and learning about psychology of how people actually use websites and computers and the like, I think is going to be really valuable. If you have a look around the internet, most of the internet sites do not implement any thought in that context. So there's already a start. We're already starting here compared to what's already available. So I think we can do a lot of stuff. It's really easy. It's just a matter of structuring it differently. So yeah, but I think that's enough on that.
So
Yeah.
I think that's maybe we can show you our initial design to show our understanding, and maybe you can give us some feedback to help us understanding what is new.
Okay. You want to draw anything, or you
We've got some.
Okay.
Yes.
So the basic idea is that in this square, so you got your steps across the top. So step 1 would be like select your area.
Mm-hmm.
Step 2 is select variables in time, time range, I guess would be called. And then you'll see your estimate and a summary, and you can download there.
Mm-hmm.
So we'd have a map here where you can select your area.
Mm-hmm.
This would be a list of stations, although I'm not sure if you have a station set up exactly.
We guess.
Yeah. No, I understand what you're doing. Yeah.
Yeah, cool. So and then you go just next step, and then we go to the next page, and you just insert your time range here. Now you might want to have multiple time ranges, and we can have like a row system for that.
Mm-hmm.
And the variables you want like wind direction, strength, humidity, temperature, stuff like that.
Mm-hmm.
With a filter, because you said there's 100 variables, so you just want to, if you want, and you don't want to look through all the checkboxes, just type it in and have it come up easily. Tick the things you want.
Yep.
Next step. Select your file format, estimated size of download, summary, and then click the download button. Now, more complicated than we think. Obviously, once we get into the data, it will
More or less, that's what you'll be doing, right?
more or less,
Yeah, this is great. The only difference here is that the really thing I really want to be able to do is have a user input their shapefile as an option
Yeah, definitely.
here. So that's because at the moment it's pretty easy to say, select a box or select a location. That's straightforward, but it's the shapefile that is something that doesn't exist, and it'd be really that's basically what people want.
We'd also want them to be able to extract the shapefile that's selected. That'd be a good feature. So say you selected and you extract that shapefile, and you can upload it later if you want to.
Yeah, I think that's a good idea. So if we implement a drawing component, and then we can say, it automatically downloads the shape that they selected. I think that'd be really good because they're tiny files.
Yeah,
So
I think it's nice to have feature.
yeah, that's right. I think that's that. And it also I know there are lots of existing web interfaces that if you can draw it, they've saved it somewhere. So
Exactly.
should be able to just output it. So I think more or less this is actually what we're after. Have you done any searching online for existing interfaces already? Okay, so this is good. I think it's great to come up with something that you guys have just sort of like, you know, more or less the interface, you know, that's great. Now what I'd really like you guys to come back to us with is, here are all the interfaces that we're aware of. It'd be great if you get started with Yost and get him to have a meeting with you guys. Probably be worthwhile me being there. I was just thinking through whether he could just do it without me. I think it'd be just a bit too confusing. He wouldn't know what you did or didn't know. So yeah. So I think this is basically the workflow we're after. The issue comes. One thing that's missing here is models.
Yeah, we need to
Model,
know what they are.
ensemble.
What was that?
And this is where hopefully you can get, if you can get access to some of the existing systems, you'll see kind of some of the complexity. So there's model ensemble member, and then there's experiment. Let me just give that a quick drawing. Oh. Got a photo?
No.
Oh.
I can remember that. It's very simple, I think.
Alright, no worries. It's easy to get it back from me as well. And I think Joel's sort of familiar with it as well. Alright, so let's say for example we've got just a really simple linear model that has a whole bunch of parameters in it. And when we run it, it has different pathways that it takes through time as we change those parameters. Okay? Each one of these would be considered, so if each one of these has, you know, AX plus BY plus CZ, you know, and A, B, and C are changed all the time. And we end up with these kind of responses. These models are each called an ensemble member. Oops. Let's say that's time. Let's say that's response. And so, and then the other word you need to understand is, better write it properly. Okay, ensemble member. So all models should have ensemble members. Sometimes they can be hundreds of thousands. We have 6 in ours. 6 models that were run from 1960 through to 2100, and they have slightly different pathways that they've taken. Different variables vary by different amounts. So the difference between rainfall might be as different as this one is to that one, whereas the differences in temperature might be like the difference between these two, for example. So they're quite similar in their response.
So that means a module like a mathematics formula.
Yeah, you can change. So models can be just a mathematical formula.
Yeah.
And they can also be a host of mathematical formulas that then create like a really, really complicated space. And so we actually use the second version. So global climate model, it's probably a presentation I should give to you guys actually. So let's do that next time. So I'm running out of time. Our models have different ensembles. You need to be able to understand that in the download. So you guys have got the system fine, but you need to build in model ensemble and also experiment is another one. So, so there's the time, there's variables, there's also the model ensemble. And when you see the directory structure, It's right there. Like it's front and foremost is what you actually have to select on, and almost you kind of need a page for each one of these, and that'll be clear when you can see the directory structure. So,
Could we perhaps get access to that tonight?
just have to think about. So I can certainly like send you a few paths, like that's super easy for you guys to just be able to see them.
Yeah.
The reason I hesitate is because I prefer that your interaction is constrained to the Nectar server that you're going to be connecting to. Partly because it means we don't have to teach you how to log into one thing and then have to teach you how to log into something else.
Yeah.
And I don't have to go and set up 7 users in our system and then delete them effectively. I prefer to have it so that we get the server set up, and let's do that quickly.
Yeah.
However, getting to understand the directory structure, I could send through something today, and maybe. So I'll send through a couple of examples with a descriptor that sort of says what the directory structure is, and I'll send through a couple of example files of NetCDF files, so that you can have a look at those.
Are you familiar with the tree command that shows the layout of the directory?
No, like not properly. I can give it a try though.
Yeah, so it'll just be like folder and then branch folder and the folders in that folder and stuff. And that could just show us the directory layout without even giving us any of the files. So in Bash, you can tree and then output that into a file and then just attach
Okay,
everything.
if you guys are happy with that,
Yeah.
I could do that.
Because I think we just need to see the directory formats.
Okay,
Like, yeah.
no worries.
Yeah, because we're supposed to be writing a report right now, not setting up anything technical. Yeah.
Okay.
Yeah, I think we start our technical stuff in like week 4.
Yeah.
Yeah.
Okay.
But once we know how these things are laid out, we'll understand the project better, I think, and we can write that report a bit nicer.
Okay, no worries. I'll send through a tree and a directory and a couple of paths, which I will do as well, because they will help explain the tree anyway. Path and explain. And
Maybe just one small NetCDF file as well.
oh, absolutely. No, I will send you those.
Read up about those file formats as well.
The NetCDF and all right, and I've got a host of things that you need. Sorry, are there any other questions? So I think this is good. This is basically where we're going. It's about adding a little bit more functionality to each step. So fantastic first step, and it's just now a matter of whether we can get you guys to understand what's out there already. Who's in charge of this? Okay. Is there anything else? Because I've got a whole bunch of stuff I want you guys to read up on.
Yeah, I think you should just show us that first, and if we have any questions, then we will.
Okay.
Yeah.
So, question: anybody here red-green colorblind? Damn. It'd be good if we had you in house, so then we'd be able to make sure our stuff's all red-green colorblind friendly. Okay. Programs to look into. Threads. Ramada. IML state portal. IMass data portal. They're both very similar. That one was built first, and then that one was built on it. It would make sense for us to actually use that, but it might not be flexible enough. I guess NetCDF is here. So those, that's kind of linked to those. And then we've got 2 other programs for those of you who are interested in new programs, NCO and NCDO. Just depends on how much reading you want to do. These are the. I don't have a symbol for this. I'll do it as this, if you're really interested. Then it'd be really interesting to see what happens when you guys try and find TCMDI and Cortex. What's another big online database? Oh, you could have a look at NASA.
The Bureau of Meteorology.
Sure.
You mentioned them before, so.
Sure, go have a look what they've got. Look at them and then look at, what is it? Climate change in Australia. CSIRO. That one is coming close to the best documentation stuff, so have a good read of that, and you might like to have a look at their stylings, just as an example of something different. That's the starting point. These ones have actually been built basically by people in Hobart in the IMAS building. The TPAC team, the IMOS team, and the IMAS team. So there's a lot of in-house help that you could go and talk to people about how their database worked, why they made that choice, what was the user interface decisions that they made. There's a lot of learning you could do from these ones. Okay, these ones here, these are kind of out-of-the-box options. So taking them and setting them up, you could, it's almost like that's what you could do with no effort, and then you could see what limitations it has. One of the things we haven't done as our team is we know there's a lot of functionality hidden away inside these options that we've never really investigated as to what we could do with it. So, and it could be that Ramada actually underpins this and this. I don't know, but it's probably, so they're the ones that I'd really have a look at. The NASA portal is definitely worth looking at. It's very similar data in terms of how you actually go about accessing stuff and taking users down different pathways is probably a really good option, because they have you've kind of got your raw data, which is your big three-dimensional cube, and then you've got like that comes straight out of the instrument, and then you can kind of like improve that and improve that and improve that, and that's what NASA does, so that most people are actually interested in their level 4 product, and so that you don't have to understand the issues with level 3 or 2, or they've got level 0, level 1, 2, 3, 4, and then they have data products, which are at the bottom. So it's probably worthwhile to understand that's a pathway that we'll actually be interested in knowing about as well. And it kind of, in some ways, on your map there, I've got ensembles, I've got experiments, and then you've probably got another one which is like data product. That's kind of like variable. So you could have like the variable option is actually just a different kind of data product. Just the variable, it's just really small because we've done all the summaries already. So, so again, there's a whole bunch of complexity here that actually in the core, at the very outset here, you don't really need to know it. There's only we can build on this as you understand the data better and the like. So I'll send through a geospatial file.
Is that the same as the shapefile?
Yes. Yeah. Now, on this, NetCDF geospatial files, language, the program you should download because it's easily the best way to understand NetCDF files. It's been written in Python, but it's a standalone executable, runs on all platforms. you can open NetCDF files with these, and it will instantly show you everything you need to know about it. So it's kind of like how you open an Excel file, and it kind of shows you straight away how it works. This does the same thing with NetCDF. There's very few programs that are as useful to visually give you an understanding. So, yeah. So have a look at that. It may open shape files as well. Not sure. Shape files, you know, in terms of their format, like I personally feel like they suck, but they exist. And I'll send one through. You guys can have a bit of a play. Languages that you know. All right. Let's start with you.
Yeah, so we prefer C#. Our team prefers C#. Yeah.
Yep.
So
You only know C#?
now we.
Well,
I-
you. What do you know?
No, I do. I know Java, a little bit of C, Python, and HTML, the type of web development thing, HTML, CSS.
Yep.
And Java, CS, HTML, and also a little bit of SQL.
Okay.
Same things.
The same for them.
Yeah, similar and MATLAB.
Mm-hmm.
HTML, CSS, and JavaScript. I'm comfortable in Java and Python, but I'm really good at C#.
Mm-hmm. Okay. And is Ruby and C#, is it?
What's that?
Ruby.
Ruby? No,
Oh.
it's Ruby.
Oh, okay, right. You guys just both nodded when I said Ruby. No, you must have just nodded when you went, you don't care, I don't care what it's written in. Okay, that's cool. Alright, so C# is sort of the one everyone's most excited about, but that's cool. And Python. So, NetCDF and geospatial files are readable through some Python libraries, so I'd strongly recommend you look those up. It'll just give you a sense of what the world is that you're entering. You won't necessarily have to use Python to solve the problem, but if you might find it easier to, like if you're having to use Python, you might find it easier to use a lot of our R tools. Because R and Python they solve the same problem. Python's more of a programming language, but if you're using Python, it's probably to do all the things we use R for. And but we don't care. It's probably worth talking to us about the workflow. And we're like, oh, here's a toolbox, and you're like, great, let's use that. So we do have some toolboxes sitting around. Okay, I have a little bit of homework. I'll send you guys that stuff through. Anything else?
At the moment.
Okay. Now, to do this list yourselves, maybe have a look for other databases so you can get a sense of how they work, options and features they have. If you can be bothered trying to find out what languages they're written in and the like, that might be useful. There might be stuff sitting there on GitHub. A lot of this is open source, so there will be open source implementations that you could use. I'd try and find those if you can. You can kind of start to see why our team haven't had time to do it. Like, there's a lot here. Being a data manager is an entire job in and of itself. Our team don't have a data manager. We've got me and Pete who do it off the side of their desk. That's a motivation that I left off. We don't have the time to actually do this properly. We're too busy off actually doing our job. So being able to get this done would be awesome. And there's an entire world of work out there in this space. So understanding all this stuff is sort of a great starting point, and we'll touch on a whole bunch of different components that you need, and it'll be a great thing for your portfolio. There you go. There's my dump. Soak that up. Let that percolate for a little bit. As you think about it, put together a list of questions. A list of questions as a group is much more useful than like one at a time. Let's keep it as Monday mornings for the moment. If you want another meeting Monday morning, or you're going to need one later this week. Initialization takes more time, so
what I think best is that we look at all these things together in this week and cover the questions and compile them into one big document, and we can meet later on next week on Monday. Are you guys okay on Monday?
Yeah.
Yes.
Yeah, so we're all free on Monday morning. So yeah, if you are not, you could send us a message and we will arrange another day. But preferably,
Monday next week is actually a public holiday, so that's not going to work for that particular one.
as I was saying.
I'm not
Yeah,
sure
yeah.
if we'll have enough questions like to constitute a meeting. I don't think we'll have a meeting. Yeah, it's probably just doable by email.
Yeah.
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 That's also good. And so then if you know, I know you guys are busy with other stuff going on. This isn't the only thing you're doing. It's the same as me, right? I've got another 15 other projects I'm managing. So the faster you can get this stuff done, the faster we can get on to actually like doing the actual work. It's really up to you guys to drive the speed of this, to see, you know, and so that we don't end up at a frenzy at the other end. Strongly recommend that everything's sort of, you know, as much effort as you can early. If that just means we get to the end where it's like, you know, and we can say to Christy, hey, you know what, these guys have actually already really finished. Now we're just like really polishing everything and making it, putting in all of, coming up with all of the would be good to haves. You know, that'd be really fun because that's actually where a lot of the really interesting novel solutions would be. But you know, I understand you guys are early on. I understand you guys have got other things on, and so you just let us know in terms of how much time you actually can allocate to this and what you can get done. Expectation management of you guys managing me is important. So, you know, what's achievable. I think a good thing was, you know, mentioning early that you guys thought it was already a database, and that wasn't quite what was happening. So, expectation management is good. And I'm going to expect you guys to do that when we say, what about this, what about this, what about this? You guys go,
Don't be a yes man.
yeah, that's right. Well, you know, you can be a yes man. You just say, well, you know, that's fine, but we have to get all these other bits done first. So it's important to mention that and to understand. So, right.
Yeah, I think that's it for today.
Great.
Right.
It's been really great. Thanks, Tom.
Yeah.
No worries. So we got Tony, Cam, Mirza,
Yeah.
Bill. He came last. Edward, Joel, and Long. Okay, cool. And so you'll be working with me. Pete will also be helping, and I haven't told Yerst about this yet, but Yerst will be helping as well. And so that'll cover off, I think, everyone that you'll need to engage with. Oh, and my mate and our other colleague, Dino. Dean is a programmer. He's been, you know, he's done work over in Silicon Valley and stuff. But he'll be useful and helpful with a number of the approaches. He doesn't do databasing though. So he's the one who set up the database, and we're like, yeah, this isn't working for whatever reasons. Possibly because we're just incompetent in that context, but that's okay. All right. Thanks, everyone. That's great.
Thank you very much.
No worries. You need to follow that?
Yeah. We've already taken one.
Got it?
That's all right.
Cool. No worries. All right. See everyone.
Yeah.
Yeah, see you.
Oh,
Yeah.
thank you.
So this is where we don't get the sorry. Will help others to make assignment one. After that, you can make the week minutes. After that, we will provide other work to share for. After that, you can make one together. Like that. That's it. Please share it in the Google Drive to other.
Yeah.
Already 20 minutes. So,
Yeah, exactly. Not a real
sure.
Maybe with
Need to make it.
and our project we can help you because you are housemate, so you should do that. Yeah, so just share your information with our later. We can talk about this whole so later in this. Thank you. I know that. See you guys. And that, I think this week I put some driver with Google Drive. One initial report upload.
Yeah.
So you check that we have some work in our part, each one. And you can check that later.
Yeah, I've seen that. I have 6 out of all.
In finance, because maybe you and me, its workload is a bit large, but after that, we didn't develop the software.
Yeah, I
so
got you.
please understanding.
Yeah, that's all right. Yeah,
that's
all
okay.
right. Yeah.
So you can do that first, or just waiting the browser to make some notes, help you make the assignment. That's up to you.
Yeah.
Because we all is recorded. Do that first, or just check the notes.